Hello dear students, welcome to maths class. Last class we discussed a new identity and that identity is a plus b whole square is equal to a square plus 2ab plus b square. Okay, so now based on this identity we have some patterns. Okay, some interesting patterns. So let us have a look at. So this is our pattern, that is 1 into 3 is equal to 3, which is equal to 2 square minus 1. Then 2 into 4 is equal to 8, that is equal to 3 square minus 1. Then 3 into 5 is equal to 15, that is equal to 4 square minus 1. Okay, write down the next few lines. Does the pattern continue like this? Okay, so if we consider a sequence of natural numbers, or if we consider three consecutive natural numbers 1, 2, 3. Okay, if we take three consecutive natural number 1, 2 and 3, then the product of the first and last, see, product of 1 and 3 is equal to 3, and that 3 is actually square of the middle term minus 1. Okay, similarly here, see, 2, 4 and 3. 2, 3, 4 are 3 consecutive. 2, 3, 4 are 3 consecutive natural numbers. Then the product of the first and last, that is 2 into 4 is equal to 8, and that 8 is actually is equal to square of the middle one minus 1. Okay, then this, if we consider this 3, 4 and 5, if we consider three consecutive natural number 3, 4 and 5, then the 3, 4 and 5, then the product of the first and last is equal to square of the middle minus 1. Now we need to write the next few lines of this pattern. Okay, so what is the next line? Yes, 4 into, yes, instead of the next number is 4. Okay, 4 into 6 is equal to, what is 4 into 6? That is equal to 24, and which is equal to 5 square minus 1. Okay, 4 into 6 is equal to 24, that is equal to 5 square minus 1. Then next line, that is 5 into 7 is equal to 35. Then which is equal to, yes, 35 is equal to, yes, 6 square minus 1. What is 6 square minus 1? 6 square is 36, minus 1 is equal to 35. 5 square is equal to 25. 25 minus 1 is equal to 24. Okay, so this is an interesting pattern, and next we are going to explain why this is happens using algebra. Okay, using algebra, how do we explain this? That is what we understood from this pattern. Yes, if we take three consecutive natural numbers, the product of the first and last is equal to square of the middle one minus 1. Okay, so here we are going to take three consecutive natural numbers. Okay, namely, if x is our first natural number, which is our next natural number? Yes, x plus 1 is the next natural number, because the difference between two consecutive natural number is always just 1. Okay, so if x is our first natural number, x plus 1 is our second natural number, and x plus 2 is the third natural number. So if we consider the three consecutive natural number x, x plus 1, x plus 2, then according to our pattern, how can we write this? Yes, product of the first and last, that is product of the first and last is equal to x into x plus 2. Okay, x into x plus 2, product of first and last is equal to x into x plus 2. What is x into x plus 2? X into x plus 2 is equal to x into x is equal to x square, and x into 2 is equal to 2x. Okay, x square plus 2x. So, for product of first and last is equal to x square plus 2x. So, we put this as equation number 1. Okay, now we are going to check whether it is equal to square of this one minus 1. Okay, square of the middle one minus 1. This is equal to, if this square of this x plus 1 minus 1 is x square plus 2x, we can say that this pattern is true for all natural numbers. Okay, so now we are going to find out square of the middle one minus 1. Okay, square of the middle one is x plus 1 whole square. Then using our a plus b whole square, using our identity a plus b whole square, let us expand this x plus 1 whole square. So what is x plus 1 whole square? X plus 1 whole square is, yes, first term square, x square plus 2 into 2ab. So 2 into x into 1. 2 into x into 1 is, yes, it is 2 into x into 1 is 2x. Okay, then plus 1 square, that is equal to 1. Okay, so x plus 1 whole square is equal to x square plus 2x plus 1. Okay, and minus 1. Okay, here we have a minus 1. So which is equal to, yes, x square plus 2x. See, same thing is adding here, then the very thing is subtracting from it. Okay, so that means this becomes 0. Okay, so here we have x square plus 2x. So from 1 and 2, from the equations 1 and 2, what we observe? Yes, here we have x into x plus 2 is equal to this x square plus 2x. Okay, and here we have x plus 1 whole square minus 1 is also equal to x square plus 2x. That means x into x plus 2 is equal to x plus 1 whole square minus 1. Okay, so this is the algebraic expression, or this is the algebraic explanation for our pattern. That is the product, if we take any three consecutive natural numbers, then the product of the first and last is equal to square of the middle one minus 1. Next, another pattern. Okay, look at this pattern. That is, this is the pattern. That is 3 is equal to 2 square minus 1 square. Next, 5 is equal to 3 square minus 2 square. And 7 is equal to 4 square minus 3 square. Write the next 3 lines of this pattern and explain this using algebra. Explain, is it true for all natural numbers or all odd numbers? Prove it using algebra. That is our question. Okay, we take only these two consecutive natural number. These two are, that is 1 and 2 are the first two consecutive natural numbers, right? 1 and 2 are the first two consecutive natural number. Then what it is? What about the difference of their squares? Their difference of their squares is equal to, yes, that is 2 square. 2 is the bigger number. Then 2 square minus 1 square. 2 square minus 1 square is equal to, yes, that is 4 minus 1, which is equal to 3. Okay, so 2 square, the difference of the first two natural, square of the first two natural numbers is equal to 3. Then consider the next two natural numbers. Which are they? Yes, 3 and 2 and 3 are the next two natural numbers. And what about the difference of their squares? That is equal to 3 square minus 2 square. Okay, 3 square minus 2 square. What about 3 square? 3 square is 9. And what about 2 square? 2 square is equal to 4. Okay, then 9 minus 4 is equal to 5. Okay, so that is equal to 5. Then if we take the next two natural numbers 3, 4. So what we have, that is 4 square minus 3 square is equal to 16 minus 9 is equal to 7. Okay, then how do we write the next line? Yes, the next line is equal to, yes, starting from this side we have, yes, 5 square minus 4 square. 5 square minus 4 square. What is it? 25 minus 16, that is equal to 9. Then what about the left hand side of this equation? Left hand side of this equation are continuously writing. We are writing continuously the odd numbers. Okay, these are odd numbers. That is the difference of, okay, the difference between the square of the next two odd numbers gives the second odd number. Okay, third odd number, like that. Okay, so then how do we write the next line? Yes, next line is equal to after 9, which is the next odd number, that is equal to 11. And how can we write it? That is equal to, yes, 6 square minus 5 square. Okay, 6 square minus 5 square. Then how do we write explain this using algebra? If we take any two consecutive natural numbers, okay, if we take any two consecutive natural numbers, say x and x plus 1, okay, if we take any two consecutive natural numbers x and x plus 1, now we are going to find out the difference of their squares. Okay, difference of their square. If the difference of their square is an odd number, then we can say that the difference of squares of any two consecutive natural number is always an odd number. Okay, if this is true, we can say that the difference of squares of any two consecutive natural number is an odd number. Okay, so here we take two consecutive natural numbers, say x and x plus 1. Then what about the square of their difference of their squares? For that, yes, x plus 1 is the bigger number. So first we are going to find out x plus 1 whole square. What is x plus 1 whole square? Yes, x plus 1 whole square is equal to, yes, first term square, that is x square plus 2 into x into 1. 2 into x into 1 is equal to 2x. Okay, 2 into x into 1, that is 1 into any number is equal to that number itself. So that is equal to 2 into x into 1 is equal to 2x itself, plus 1 square is equal to 1. Okay, so what about square of x? Square of x is equal to x square itself. Okay, so now we are going to find out the difference between the squares of two consecutive natural numbers. So that is equal to, yes, x plus 1 whole square minus x square. Okay, x plus 1 whole square minus x square. That is equal to, yes, what is x plus 1 whole square? X square plus 2x plus 1 minus x square. Okay, see children, here we have a plus x square and the same x square is subtracting from here. Okay, so what is remaining here? Yes, it is only remain here, that is equal to 2x plus 1. But is it a natural, is it an odd number? How can we check is it an odd number or not? If we give different values to x, then if the answers are only odd numbers, we can say that this is the general form of an odd number. Okay, let us find out is it the general form of an odd number. Okay, this is our general form. Okay, so here I am going to give different values for x. Okay, if I give x is equal to 1, what happened? X is equal to 1 means in the place of x, we just give the value 1. So 2 into 1 plus 1, that is equal to, yes, 3. Okay, then if x is equal to 2, x is equal to 2. X is equal to 2 means, yes, in the place of x, we just substitute 2. That is 2 into 2 plus 1. 2 into 2 plus 1, that is 4 plus 1 is equal to 5. Then x is equal to 3. X is equal to 3, that is, yes, 2 into 3 plus 1 is equal to 7. That is, if we give different values to this x, we get all natural numbers like this. That means this is the general form of, that is, if we give different values to this expression, we get all odd numbers. All these are odd numbers. Okay, if we give any number, this expression gives only odd numbers. Okay, so that we can say that this is the general form of an odd number. So we can conclude that if we take any two consecutive natural numbers x comma x plus 1, then the difference of their square is an odd number. This is the general form of an odd number. Okay, so what is our conclusion? Yes, if we take any two consecutive odd numbers, the difference of their squares is equal to an odd number. Okay, so we can understood from this pattern. Okay, now we are going to do the problems in page number 84. That is the third exercise of this chapter. Okay, look at the first question. All of you take page number 84. Question number 1. Is there a general method to compute the square of numbers like 1 1 by 2, 2 1 by 2, 3 1 by 2, etc. Explain it using algebra. Okay, so here we have some numbers, that is 1 1 by 2, 2 1 by 2, 3 1 by 2, etc. Okay, then we need to find out, is there any simple method to calculate square of these type of numbers. Okay, and we need to explain that using algebra. So here I am going to take the first number 1 1 by 2. Okay, 1 1 by 2 means it is, what is it actually? It is actually 1 plus half. Okay, 1 plus half. Then what about its square? What about 1 1 by 2 square? Yes, 1 1 by 2 square is equal to 1 plus half whole square. Okay, 1 plus half whole square. Then using our identity a plus b whole square, how can we expand this? Yes, this is equal to 1 square plus 2 into 1 into, next number is 1 by 2 plus 1 by 2 square. Okay, so that is equal to 1 plus, yes, 1 square is 1. Then here we have 2 in the numerator and here we have a same 2 in the denominator. So let us cancel that 2. Okay, so here we have 1 into 1, that is equal to 1. Plus, yes, what about 1 by 2 whole square? This is a fraction. A fraction square is equal to numerator square, that is 1 square is 1, and denominator square, 2 square is equal to 4. Okay, so square of 1 1 by 2 is equal to 1 plus 1 plus 1 by 4. Okay, so keep in mind this. Okay, square of 1 1 by 2 whole square is equal, 1 1 by 2, square of 1 1 by 2 is equal to 1 plus 1 by 4. Okay, now the next number, which is the next number, 2 1 by 2. Okay, next is 2 1 by 2. So 2 1 by 2 is 2 plus 1 by 2. And what about 2 1 by 2 whole square? 2 1 by 2 whole square is equal to 2 plus 1 by 2 the whole square. Then using our identity a plus b whole square, let us expand this. That is 2 square is equal to 4 plus, yes, 2 into 2ab, that is 2 into 1 by 2 plus 1 by 2 whole square. Okay, so here we have, yes, 4 plus, yes, this 1, 2 and 2 get cancelled, then 4 plus 2 plus 1 by 4. Okay, 4 plus 2 plus 1 by 4. Now we are going to find out 3 1 by 2 whole square. Okay, that is equal to 3 plus 1 by 2 the whole square. Then using a plus b whole square, we have 3 square plus, then 2 into 3 into 1 by 2, 2 into 3 into 1 by 2 plus 1 by 2 the whole square. So that is equal to 9 plus, yes, here also we can cut this, 9 plus 3 plus 1 by 4. Okay, 9 plus 3 plus 1 by 4. What about our 1 by 2 square? Yes, 1 by 2 square is equal to 1 plus 1 by 4. Okay, what about 2 1 by 2 whole square? That is equal to 4 plus 2 plus 1 by 4. Okay, then what about 3 square? 3 1 by 2 whole. So we have, yes, 1 by 2 square is equal to 1 plus uh, 1 plus 1 plus 1 by 2. This is equal to 4 plus 2 plus 1 by 2, 1 by 4. And 3 square is 9 plus 3 plus 1 by 4. Then what about 4 1 by 2 1 square? How can we find this? That is equal to, yes, 4 square. This is 3 square. This is actually 3 square. This is 2 square and this is 1 square. So 4 square. 4 square is equal to 16 plus this number itself 4 plus 1 by 2 whole square, that is 1 by 4. So how do we find the square of these type of numbers? Yes. Then can you say the square of 5 1 by 2? Yes. First 5 square, that is 25 plus then the number 5 plus 1 by 4. So this is the easy method to find the square of these type of numbers. Now we need to explain this using algebra. See children, I would like to give the explanation of the algebraic form of this pattern as an homework. So that is an homework. So children, thank you.